Today we are going to do section 2.4 and on page 125. Now we are going to learn something called complex numbers. What's a complex number? It is I. What is I? I is the number, so I is the square root of minus 1. Now, at this point, you might wonder, I thought you can't take the square root of negative numbers. You can't in real numbers. Real numbers, the stuff means the numbers we use in real life, such as 1, 2, -5, pi, that sort of thing. Whereas the complex numbers, however, also called imaginary numbers, are not used beyond the real number system. Okay, so we have this thing that is imaginary or made up, such that we will call the square root of minus 1 as I. Okay, so I has one meaning. It is the square root of a negative 1. Now, remember that I is imaginary, so do not try to match it to anything in real life. In other words, I is kind of like SpongeBob, okay? It's imaginary. Do not sit around and wonder how can a sponge possibly talk and work and cook burgers and stuff. You're wasting your time. I is imaginary, okay? And so do not try to match it into anything in real life or try to understand it that way. I is imaginary, and its meaning is that it is the square root of negative 1. That's it. Okay, so now that we know that, remember that one thing. And because I is the square root of negative 1, that means I squared, I squared, that is, if you take I multiplied by itself, that will be equal to the square root of negative 1 times the square root of negative 1, and that of course will equal to negative 1, because anything the square roots multiplied by themselves is the number itself. That's the meaning of the word square root. Okay, so the first thing we know is I squared does equal to negative 1. Being that I is the square root of negative 1. So now, with that, we can calculate the square root of negative numbers, which is the whole purpose, whole point of the existence of I, is to calculate the square root of negative numbers. Now let's look at the next page, where we, so we're now on page 126, where we calculate, for example, the square root of negative 49. Now the square root of negative 49, now that we know that the square root of negative 1 is I, this square root will be calculated as negative 1, okay, times 49, all under the square root sign. So that would be equal to, with the rules that we have learned, that would be equal to square root of minus 1, and then we can take the 49 out because it's not negative anymore, and that is 7. In other words, this is equal to 7i, whereas I stands for the square root of negative 1. All right, so that is that. And with this kind of information, that's how we're going to do the entire rest of the section. That is, we're going to treat I like any other variable, like x or something, with one exception, that we always remember that I squared is negative 1, or I is the square root of negative 1. Now, having said that, let's look at example 1, where we take the square root of 9. So the square root of 9, similar to the square root of 49, we take the negative sign out, okay, take its square root, which is I, and then we take the square root of the regular 9, which is 3. So the answer is 3i. And sometimes we might even write it as, let's look up this page a little bit, where all numbers now are written like this. For example, you might have a number that say 1 plus I, then that is just that is. So all numbers now have a part that's called real and a part that's called imaginary, and so this is called a standard form. So you write down its real part and imaginary part. Now, for example, this number 7i, you can write it as 0 plus 7i. And then all real numbers, of course, now become, say, 5 is now 5 plus 0i. But we're not going to do that, really. I mean, if it's 0, we just skip it. Okay, but if it's not 0, then we will put a number in. So that, in other words, the complex numbers include all real numbers as part of its collection. So complex numbers then have real numbers in it. It's just that it has I is 0 for the real numbers. And then the rest of the complex numbers will have I in the number. Now, either way, that is that is that. So let's go to the next page. What's the next page? 127. And then let's look at this stuff. Okay, 127. We're gonna plot this thing on the graph. Now, how would you plot this 1 plus I? What we do is we do the same thing that we've been doing with the xy axis. However, for now, this is now called the real axis, and this is called the imaginary axis. Okay, so this is real, and that's imaginary. And then, so to plot, for example, 7i, this is the I direction. So 7i, you just go up 1, 2, 3, 4, 5, 6, 7, and then it has no real numbers. So 7i is right here. 7i. All right. And similarly, if we were to plot like your book ones on this page, -2 plus 3i. So you go -2 on the real number, okay, and then positive 3i on the imaginary scale. So it's about here. So that thing is called -2 plus 3i plus. All right. So as you can see, it plots very similarly to the regular xy axis that we normally use, and that is how the numbers are represented, because the real number is represented on the line, right? We have this is called the number line, where you have 0, and then you have average various numbers in here, such as 1, 2, 3, and you even have pi in there, 3.14. Here's our pi. And then the negative numbers the same way, -1. But the imaginary numbers does not fit into the real number. So the imaginary number, we have another axis that comes out. Okay, so like this, and that's how we plot imaginary numbers. As you can see, the imaginary numbers contain the real number line, which is the x-axis. So all real numbers are in the imaginary plane. So imaginary numbers are represented by a plane, whereas real numbers are represented by a line, because imaginary numbers, has two directions to think of. Okay, so that is how we do that. Now, having said that, let's look at example 2. We're plotting some complex number 3 minus 4i on the plane. So that's how we're going to do it. So we're going to positive 3. Okay, we are doing 3 minus 4i. So we're going positive 3 in the x direction, and then in the I, which is the y direction, we go down -4, because it says minus 4i, and that dot is the negative 3 minus 4i graph. And by now you may think that seems a bit confusing, that this thing is identical to the xy plane. But for now, let's suspend, not think about the xy plane, and focus solely on this thing. Okay, right now we are just the y-axis for this section only will represent the imaginary axis, whereas the x-axis is for now the real axis. And with that solidly in your mind, then you'll be able to handle this easily. So next, let's look at example 3, and now we are at page 128, where we have a problem of addition. Now, how do you add? Let's look at the formula first. How do you add and subtract complex numbers? Well, you add it and subtract it as if it's like an x or something, like a variable. For example, let's see a plus bi, right, and c plus di. So you will add a and c, and then add b and d. And b and d will end up being the I part. And similarly, with subtraction, you will do it as if I is the variable x. Now let's do an example of example 3. Now let's do example part B. Okay, part B, this is what? Example 3b. We will do minus 5 plus 7i, and then subtracted by -11 plus 2i. Now at this point, we have first, we do the same thing we always do when it comes to parentheses. We get rid of the parentheses, so this becomes minus 5 plus 7i. And then the negative, we'll knock out each one here to change it, so this becomes a plus 11, and then a minus 2i. So at this, remember, at this point, I is just like a variable like x or something. You work with it the same way. So the next step is we'll round up all the numbers. So minus 5 plus 11, that's 6. And then plus 7i minus 2i, that would be plus 5i. See, I is like x in this case, and that should be our answer, and it is. So that is, that's that. And now you might wonder why are we even doing this? And the thing is imaginary; it doesn't even exist. Well, there is a point to it. Okay, it does come in handy in some math areas. So, so for now, you are just being introduced to the concept of the imaginary number. So just hold on to your belief and not worry about what is good for anything. You know, the same as SpongeBob. What's SpongeBob good for? Who cares what he's good for? You know, he's great. So that's why we have his picture up, even though he is imaginary. Now the same with a complex number. Let's look at example 4. The same principle here. Now we have example 4. We need to multiply 4 times a complex number. So we have 4 times 2 plus 5i. Now the I, as I have mentioned, is consider it like x. Okay, so you just multiply it as if you're doing x. So then you have 4 times 2 is 8, and then 4 times 5 is 20, and then the I is still there. So you leave it there, and that's the end of that example. Yeah, so please do the examples I've mentioned so far, 1, 2, 3, 4, and actually all the rest of them too. So the next part is how are we going to do complex number multiplication if you have 2 complex numbers? Well, we are going to do it the same way we always do. Okay, like let's look at the next example, example 5. On page, the following page, 130. So now let's go to page 130 and then look at example 5, which states that, here's our problem. Let's see, 4 plus 3i times, now we're multiplying 2 complex numbers, 2 minus 5i. Now we are going to do this exactly like we would multiply if this was x, okay? As we multiply this, each member of this group shake hands with each member in the other group 1 time. Nobody shake hands with their own group, okay? So first 4 times this, okay? 4 shake hands with each guy. That's 4 times 2. I will just write down 8. So 4 times 2 is 8. And then 4 times negative 5 is 20 minus 20. I stays with it like x. So this guy is done shaking. Next guy shake hands with all the guys here is plus 3i times 2 is plus 6i. And then plus 3i minus 5i is minus 15i. But this time I is squared. Okay, so just like x. Now, at this point, we will clean it up a little bit, but we're going to pay special attention to this. What is I squared? As I've mentioned before, I squared is negative 1. That's another way of saying square root of 1 equals to I. So I squared equals to negative 1. And whenever you see I squared, you have to immediately replace it with negative 1. So then this becomes positive 15 because it's negative 15 times minus 1. So that's positive 15 plus 8, that's 23. So 8 plus 15, okay? And then minus 20 plus 6, that's minus 14. And that should be our answer if I didn't mess up. Yep, that is correct. And that is how it is done. Anytime you multiply i's, you do it just like all other ways, with one exception is I squared is negative 1. Because that's the meaning of I, okay? I mean, without it, it has no meaning at all. So I has one meaning, and you have to bear in mind. Anytime you see I squared, you have to turn it into negative 1 and then multiply it accordingly. Well, basically what you do is you change the sign of the number next to it. So that is that. And then so next we are going to do the division. Now to do the division is where's the example? Okay, now for division, first we have to find the conjugate. the conjugate, it means a number with when you switch the sign of I. Let's look at example 6 to see what a conjugate is. Okay, now example 6 has two imaginary numbers. Now here's 2 plus I times square root of 5. What's the conjugate? The conjugate is you switch the plus in front of I into negative. That is you switch the sign in front of I. That is conjugate, then is 2 minus I square root of 5. And then part B is what's the conjugate of negative 1/2 I? Well, switch the sign in front of I. The conjugate is positive 1/2 of I. That's it. It's a very quick answer. Okay, so please do example 6, and then we are going to do example 7. So I want to clean off the board. So example 7, we need to calculate 2 plus 5i divide by 4 minus I. And how are we going to do that? When we have a division sign, we're going to pull off this trick that we learned some time ago that is called the difference of squares. That is, we'll take advantage of the fact that a plus b times a minus b is a squared minus b squared. So that's the same trick we're going to do here. Is we're going to multiply this thing by the conjugate, which is of the denominator. And there's a reason for that, and we'll see that in a moment. So we multiply it by 4 plus I. See, the conjugate just switches the sign before I, so it becomes a plus, and then we do the same thing here, plus I. Now, if we do that, then, well, the top multiplies together. Okay, we'll put some parentheses here to see it better, and then do the multiplication. Now, as always, we do the multiplication by 2. Take the first one, okay, shake hands with each item in the next bunch. So then 2 times 4 is 8. And then 2 times I is 2i. And then 5 times 4 is 20i. And then 5 times 1 is 5i squared. Okay, don't forget the squared. And then, of course, I squared is negative 1. So this thing is the same as negative 5. But we'll deal with that in a little bit. Now, next, we'll do this. Now, this is a difference of squares. And by the difference of squares formula, we can directly write down this is equal to 4 squared minus I squared. Again, I squared is negative 1. Okay, and this is... And the purpose of doing this is so that the denominator doesn't have an I in it, okay? Because I squared is minus 1. So by pulling this conjugate trick, we got rid of the I in the denominator. But we still have, we'll still end up with some fractions probably, but that's okay. We just don't want I in the denominator, okay? We want I in the numerator. Only that way we can plot it on a complex graph. Good. Okay, so having said that, then we have, so now we're gonna do the details, okay? This is plus 5i squared, which is minus 5 because I squared is equal to negative 1. That's right here, right? So this is minus 5. So we have 8 minus 5 is 3. Plus 2i plus 20i, that's 22. And then on the bottom, I squared is negative 1. So minus negative 1 is plus 1. So that's 4 squared is 16. So that gives us 17. Okay, so because your minus negative 1 is the same as adding 1. So we have 16 plus 1 is 17. And that should be right. Yep, it is. And well, your book have it written in 2 separate forms, which is okay. So we'll do that. 17 plus 22i over 17. And it's okay that the numbers are in fractions. Okay, there's no rule against that. And this is the answer to the division problem. So next, let's go to page 132, where we consider certain qualities of I. Now, what about it? Well, I is just I, right? And then, of course, we know that I squared is 1 because that's how I is defined. So I squared is 1. But what if you have I3? Well, I power 3 is just I squared times I itself. And I squared is negative 1, sorry. I keep forgetting the negative sign. Don't ever forget the negative sign. So I squared times I, which is end up being negative I. See? So, and then I fourth, if you keep going, you notice that I fourth equals to I 3, okay, times I again, which is equal to minus of I squared is negative 1. So that becomes positive 1. So what that means is every fourth power, I becomes 1. Okay, now how interesting is this? So then what that means is that you can keep going, right? Because then what happens is, like your book says, then once you know that I4 is 1, then the cycle repeats itself. Because I5 is just I4 times I, is I again, I6 is negative I7 is negative, I6 is negative 1, I7 is negative 1, and I8 is 1 again. So every 8 times, multiplying itself, it will become 1. And to demonstrate what that means, let's look at example 8, okay? And where we calculating I35. Now that sounds like a lot of, now instead of going through one at a time, remember every 8 times multiplying itself, it becomes 1 again. So I35 equals to I30, 4 times 8, okay? 4 times 8, why did I have 2 there? 4 times 8. Now each I to the power 8 is 1, right? So 4 of them is still 1. So that 4 times 8 times I3. So that would be equal to, so this is equal to I 4 times 8, that's 32, plus 3 is 35. Now this multiplied together, this is just 1. Because it's 1 multiplied by itself 4 times, still 1. I3, as we have here, is equal to negative I. So the I35 is just negative I. So the I basically cycles itself. It goes back to where it come from. And then and just keep doing that. If you multiply it by itself, it just keeps spinning around. All right, so that is that is example 35. So please do that as part of your homework as well. And that should come to, that is the end of this section. Now for homework of this section, please do problems 5, 9, 11, 13, 17, 21, 25, 29, 31, 33, 35, 37, 39, 47, 49, 51, 53, and 55. And that sounds like quite a number of problems, but notice that most of the problems go pretty quickly. As long as you remember this, I squared is negative 1. And then, and whenever you do division, don't forget to pull out this trick of the conjugate business. Okay, you just multiply it by the conjugate, and everything will come out nicely. So please go do your homework, and when you get back, I want to talk about some of them. So now that you're done with your homework, let's talk about it. First, let's look at problem 5. If y is x squared plus x minus 4, and then x is 2i, we need to calculate what y is. So y equals to x squared, which is 2i squared, plus x, 2i again, and then minus 4. All right, so that let's crank that out. So that will become 4i squared, I squared plus 2i minus 4. Now, remember, I squared is negative 1, so this is a negative 4. Okay, so then we have negative 4 and negative 4 again, that's minus 8. It's just minus 8. There's no I there because I got squared. So that's negative 8 plus 2i. And that should be the answer. Yep, and it is. So next, let's look at problem 9. Problem 9, I have x equal to 5i. So next, problem 9. X equals to 5i. So we have 5i plus 1, okay, x plus 1 over 2 minus x. So 2 minus 5i. And we're supposed to do something with this. And do they want us to simplify it? Yes, they do. So we are going to simplify it by the conjugate trick, okay, this one, where we multiply it by switching the sign of what's on the bottom. So this is 2 minus becomes 2 plus 5i on both top and bottom. And then we just multiply this thing out. And then, so on the bottom it becomes 4, okay, minus 5 squared I. 2 times, okay, that means it becomes 4 plus 5 squared because I is also being squared. Okay, and so anyway, so we'll think about that later. And right now we'll do the multiplication, which is 5i times 2, that equals a 10i. 5i times 5i is 25i squared. And then this one, 1 plus 2 is 2. And then 1 plus 5 is 5i. I'll make my division line a bit longer. All right, so then we have to add this up. So we have 10i plus 5i, that is equal to 15i. And then, right, and then this 25i squared is just -1, so it switches the sign. It becomes -25, and then plus 2, it will become -23. And then the bottom is I squared, again switches the sign, it becomes plus 25, plus 4 is 29. And that should be the answer, -23 plus 15 over 29, that's correct, okay? Your book has it split into 2 fractions, but I would accept this one because I don't want to bother writing anymore. So next, let's move on to problem 21. We have 21, where is it? Okay, so we have 5 minus 2i times something called 3i. Now, as always, we multiply this stuff as if I is x, okay, just some variable. And we multiply it the same way, which is we take each guy here and multiply with everything on that side 1 time. So 5 times 3, that's 15i. And there's nothing else, so we'll move on to the next guy. So the next guy is -2i. The negative sign follows it, okay? So minus 2i times 3i, that would be equal to minus 6i squared. Now that will equal to, this would normally be the answer, except that you notice there's an I squared, and as always, I squared equals -1. Therefore, we have this, which means this sign gets changed to be positive 6, and we'll write it as 6 plus 15i, because the 15 is positive. So that should be the answer. Now let's check the answer, 21. Yep, 6 plus 15i, that is correct. So next problem, number 25. So 25, we have minus 1 plus 2i times minus 2 plus 3i. All right. Now again, we'll do this as if I is a variable. Okay, multiply the same way. We have so each item here will multiply with each thing in the other side 1 time, like shaking hands. This group will shake hands with that group. Nobody shake hands with their own group. Okay, so first we'll start with -1. -1 times -2, that's 2. -1 times positive 3, that is, oops, sorry. That is -3. So I should not have written that down so soon. So that becomes negative, see, -3i. And then, so that guy's done. Next, this guy stands up to shake hands. This guy shakes hands with the first guy, which is minus 4i. And finally, this guy shakes hands with the last guy. 2 times 3 is 6i squared. So far, so that's good. So we have the number, the numbers are, we have 2 here. This is a plus 6i squared. I squared is -1. Therefore, it becomes -6. So we have 2 minus 6, which is minus 4. And then minus 3 minus 4 becomes minus 7i. And that should be the end of that. 25 minus 4 minus 7i, that is correct. Okay, next problem. I want to do 33. Let me find it. Problem 33, which is a fraction, okay? So 33, we have 3 plus 4i 2 minus I. All right, so we are going to pull the same trick, this one right here, which states that we're going to do the plus and the negative. You always switch the sign in front of I, okay, not that other one. Switch the sign in front of I, which give us, that becomes the plus here, okay? So this is 2 plus I, the same thing on top. And then we just multiply this stuff out, top and bottom. And that will give us the answer. To multiply this stuff out, we have 3 times 2 is 6. Okay? And then 4 times 2 is 8 plus 8i. And then, sorry, I was not being systematic. We need to do it one at a time. Okay? So we have 3 times 2, and then next 3 times I is 3i. And then plus 4 times 2 is plus 8i. And finally, 4 times I is 4i squared. And then the bottom, of course, is a squared minus b squared. That is, it's going to be equal to 4 minus I squared, because that's just I times I is I squared, following this formula. And then that will give us, we'll clean this up a little bit to give us the answer. And that equals to, so we have 6, okay? I squared is -1, so it becomes minus 4. 6 minus 4 is 2. And then plus 3 plus 8 is plus 11i. And then divided by 4 plus 1. Okay, I squared is -1, so minus -1 is plus 1, which gives us 5. And that should be the answer. Let's check 33. 2 over 5, 11 over 5, that is correct. Now clean off the board. Next, let's do problem 35. Now, we have square root of -9. Now, anytime you see a negative sign, you can just take out the positive number and write down I for it. That is, square root of 9 is the same as 9i. Square root of 9i. And then 9 still need to take the square root of, okay? But at least you can just take the I out. Plus 3 times the same thing here. That is the same as square root of 16 times I. So that together becomes, that's 3i. That's 3, okay? That's square root of 16 is 4. So we have 3 plus 3i plus 3 times 4i. That's 12 plus 3. So the whole thing becomes 15i, and that should be the answer. Let me see, what are we doing? 35? Yep, that is correct. So next, let's look at problem 37. Problem 37, similar one. Let's do that. So 37, we have the problem says 2 plus the square root of -12, which is just the square root of 12i, okay? And the whole thing is divided by 2. That we'll break that into 2 fractions. That becomes 2 over 2, and 2 over 2 is 1, okay? And then the square root of 12 is the same as the square root of square root of 4, okay? Times square root of 3i, with the I. Is that 12? Yeah. And, well, I'll write this down like this. We'll keep the 2 there. Okay, that's 2 over 2, and then this is 2, both sides. Now, square root of 4 is 2, okay? We cancel this one out, so our answer then should be 1 plus square root of 3 over 2i, because the 4 got canceled out. Let's see, what is this problem? 37, 3. No, let me see. The book doesn't give the same answer. Let me check to see where I messed up. Oh, I just looked at the wrong problem. Actually, this is correct. It's 1 plus square root of I plus square root of 3, right? But where's the 2? Oh, the 2 canceled out, right? There's no 2. Now the answer is correct. Okay, so that's 37. Next, let's look at problem 47. Problem 47, we have a bunch of i's on the bottom. All right. Next, let's look at 47. We have 1 over I, and then 4 over I to the power 3. Okay, now as always, if we have I on the bottom, we'll multiply it by something to make it change. Well, we multiply it by the conjugate. So being that we have two fractions, we'll multiply each one by its own conjugate. So what we're going to do, as we always did, is so 1 over I will be multiplied by the conjugate, which is negative I. Okay, and then the same thing here. This is 4 over, what is I cubed? I cubed is I squared times I, which is negative I. Okay, so this is negative I, so we multiply it by its conjugate, which is just I. Here we are, and then we do the math. Now I times I is I squared, which is minus 1 times negative sign is positive 1. So this whole thing end up being just I, this part, just negative I. Okay, and then this, over here we have a similar situation. I squared is negative 1, and then negative 1 is another negative sign is positive 1. So that is just 4i, and we can add this stuff up, and it becomes 5i, and that should be the right answer for problem 47. Did I miss a sign here? Let me check. Why? I mean, it's a negative I there. Why didn't I see that? It's not 5. Minus I plus 4i is 3, right? I mean, everybody knows that. Anybody knows that. Anyway, so let's change it to 3, and then let's see, what does the answer say? Yeah, the answer likes that much better. Okay, so that's problem 47. And next, we need to do problem 49. All right. So problem 49, we have I7 times 1 plus I squared. All right. Now, before we figure out what I7 is, this problem is, there's a slight trick in here. So what is I squared? I squared is negative 1, as we have said, right? So then 1 plus negative 1, that's 0. Okay, there's I7. Anything times 0 is 0. Okay, so this answer is 0, period. We don't even care what I7 is. And that's the answer of 49. Yep, 0. Okay, so that's there's a shortcut, so to speak. And then next, problem 49. No, we already did that. Next, problem 51. Okay, so we have this thing. Problem 51, we have a multiplication happening. 2 plus I, and then 4 minus 2i, divided by 1 plus I. Now the first thing we need to do is multiply this thing out. And the same way we always did. Okay, each guy shake hands with each other guy. And so I'm going to do this quickly because I'm running out of space. But the principle is the same. We do it like we always do. So 2 times 4 is 8. Okay, and then we have plus 4i minus 4i, and that's 0. And then the last term is plus I minus 2i, that's minus 2i squared. And then the bottom, we still have 1 plus I. So we'll multiply this thing by its conjugate. Okay, the bottom's conjugate, which is 1 minus I. Okay, both here, 1 minus I. And then we are going to multiply this stuff out. To multiply that out, we will have, let's see, this is I squared is negative 1, so this is the same as plus 2. We'll cancel that out. So that's the same as 8 plus 2, which is 10. Okay, so we have this whole thing, this part just equals the 10. We have 10 minus 10i then on top. And then the bottom will be equal to 2, because 1 minus negative 1, that's 2. So the answer should be 5 minus 5i, if I didn't mess up. That is problem 51. Yep, it is correct. Now, I did this a bit faster, but you just go do it the same way you always do, okay? If you can't catch up as fast, it will come up with the same answer. That is, this will multiply by that, and then that, and so on. But anyways, so this problem is longer than the others, but no harder, okay? It just takes longer. A longer problem is not necessarily a harder problem. Next, we will do problem 53. Okay, let me clean off the board. So next, let's look at problem 53, where we have 3 plus I squared and then 1 plus 2I squared. We can do this the same way we always do. The square just means this thing is multiplying by itself, the same deal. So we'll do that. 3 plus I, 3 plus I. And then the same as the bottom, okay? This thing is multiplying by itself. We'll write it out so that 1 plus 2I. All right, and then we'll do the multiplication like we always do. So that would become 3 times 3 is 9. And then 3 times I is 3I. That's for the first 3. And then secondly, I times 3 is also 3I. And then I times I is I squared. Doing the same thing for the bottom. 1 times 1 is 1. 1 times 2I is 2I. And then, so that guy's done. Next guy up. 2I times 1 is 2I. And then finally, 2I times 2I is equal to 4I squared. Okay, so the next step we need to do is, now we're done with, we need to simplify it. That would be I squared is equal to -1. So we have 9 minus 1, that would be 8. Okay, so that's plus 3I would be 6I. And then this is 1, okay? 4I squared is -1, so this becomes -4. -4 plus 1, that will give us -3. And then this becomes 2 plus 2 is 4, 4I. All right, so far so good, but we still have an I in the denominator, and we don't like that, okay? Anytime you see an I in the denominator, you automatically pull out this trick, the conjugate trick of switching the sign before I. In this case, we're going to turn this plus into a minus. We're not going to do anything to this, okay? The real number doesn't need switching. Only the thing before I, that way we can apply this trick. So change thing 4I into -4I. We have, and multiply by the same thing on top, -3 minus 4I. So these things are going to be multiplied together, all this stuff. Parentheses means multiply. All right, so then we have, keep doing the math. We will have, first 8 will multiply by each guy here. Okay, so 8 times -3, that's -24. And then 8 times -4, that's 32I. And then, so 8 is done. Next, 6 times -3I. 6I times -3, that's -18I. And finally, 6 times 4 is 24I squared. And then the bottom is easier, however, because the bottom is just A squared and B squared. So A squared is 9, okay, minus B squared is 16I squared. Okay, so then following this formula. Or you can just multiply it out very quickly and you will see why this is true. Okay, either way works. So now we're almost at the end. The reason we do this is because I squared is -1, and then we got rid of the I from the denominator. Okay, so then the denominator then becomes 9 plus 16, being the I squared is -1. We change the -16 into a plus. So 9 plus 16 is 25. And then on top, first we collect the numbers. The numbers are 24, and then this becomes a plus 24. So that would be a total of 48. Okay, because I squared is -1, which knocks out the I into a positive sign. Knocks out the negative sign into positive. So that should be 48. And then these just add up, becomes a what's 32 plus 18? That would be 50 or something. Yeah, I think so. So 50i divided by 25. That's about it. That should be the right answer. So what problem is that? 53, let's check. I equals to minus 2i. Let me check to see where I got wrong. Oh, I did not see the negative sign here. See, it's actually minus 24. That's a plus 24, so this is 0. There's nothing here. Okay, so the answer is just minus 50 divided by 25. That's negative 2. So the answer is simply negative 2i. That's why. Yeah, I did not see the negative sign for some reason. Well, anyway, so once I caught the mistake, then I got the right answer. And it's always nice to get the right answer. So next, problem 55. So the last problem we have is problem 55. We have now we have 2 of them. Okay, we are just going to use the common denominator by multiplying these 2 things together. And by doing that, we will have 2 fractions like this. We'll have I times 1 minus I over here. Okay, the same thing here. 4 plus I, we'll multiply it by 1 minus I. We are multiplying by the same thing, so this cancels out to become that. So these are the same objects. And then similarly, we have 3 minus 4i divided by 1 minus I. And then we will, why did I write a T there? Okay, now see, 1 minus I, and we will multiply it by I, top and bottom. And the reason is so that the i's cancel out, and that looks identical to what we had before. So this equation checks out. Okay, now after that, we are going to, so the denominator then becomes something. We'll deal with that in a second. And, well, maybe I should write it over here. So this, I will multiply out, okay? We have the same denominator now, right? So we'll multiply this stuff out and add it up. So this is 4, okay? And then 4 minus 4 plus 1, that's minus 3i. And then this is minus I squared. Keep going. That is, should have parentheses here because I is being multiplied by the whole thing. So that is plus 3i. And then minus 4i squared. And then the denominator is equal to I minus I squared, which is I squared is negative 1, so I'm just going to write that down here. Okay, I times I squared. So we got to this point. Yeah, maybe I should have wiped the board first. Anyway, I will keep going and hope that I have enough space, although I don't see how. And so we have, first we look at the numbers. Now remember, I squared equals to negative 1. So this is 4 plus 1, that's 5. Okay, and then over here is plus 4. 5 plus 4 is 9. So the number up here should be 9. And then this is minus 3i plus 3i, that there is that's 0. Okay, yeah. So we have 9 over I plus 1. And then we have to pull that. So far so good. We have pull this trick again. The conjugate trick, where you have I plus 1 is the same as 1 minus I. Or I minus 1. The conjugate is to change the sign of the number before I. So only the i's gets their signs changed in the conjugate. So we'll do the same thing on top. Okay, so that way we can come up with a decent answer. And we have just a tiny little bit of space left. So this is I times I, that's negative I squared. And negative I squared is positive 1, right? I squared is negative 1. So the bottom will end up being 2. And the top will be 9 minus 9i. Okay? And that should be the right answer. 9 over 2 minus 9i over 2. That's correct. Okay, awesome. Now, because most of the time when I do a big long thing, I always mess up somewhere. But this time I didn't mess up. It's always awesome when I don't mess up. So this time we got the right answer, and that should be the end of this section.